our next speaker for this morning is Mark Howden. And if I just get back to here, where did that go? Now, Mark has worked on climate variability and climate change, innovation and adoption issues for over 30 years in partnership with many industries, communities, policy groups, via research and science policy roles. And we're especially pleased at Farmers for Climate Action to have Mark as a kind of a special advisor, I guess. He seems to be always willing to help us, and we're most appreciative of that. He's been a major contributor to the IPCC since 1991 and had roles in the second, third, fourth, fifth, and now the sixth assessment reports of the IPCC, and won a shared Nobel Prize with the IPCC participants and our Gore. Now, Mark will bring us up to date today with the latest climate outlook and climate change impacts and the outlook for future impacts and drought. So I'll hand over to Mark without further ado. Thank you, Mark.
Yeah, good morning, Peter, and thanks for the intro and thanks for the opportunity to speak here this morning. So what I'll do is I'll give a quick run through of sort of some of the I guess the climate change story and then sort of field questions. So I'll put up my presentation. Can you see, Peter, a thing with a signpost on it?
I can indeed see our changing climate, the past and future.
Yeah, and so when Peter asked me to do this, I thought, you know, I could sort of give a presentation which is all about the sort of future projections, and there's lots of criticism about those in the media and how reliable they are. And so what I want to do here is actually look at where we've come from and how we're tracking right now as a guide to where we might be going in the future. And that's why I've got the sort of signpost up there. It's about understanding our climate so that we can manage that combination of risk, opportunity, so we can actually be successful, the sorts of things that Rob was just talking about. So if we look at the underlying issue with climate change, it's greenhouse gas emissions, particularly carbon dioxide. And without wanting to go into this in too much detail, is that we can see this is the carbon dioxide emissions over the last 30 or so years. It keeps on going up with a few little dips in there. And this is in billions of tons a year. So it's, you know, we're now emitting something like 38 billion tons of carbon dioxide just from the industrial, you know, fossil fuel sector. So this isn't the complete balance. This is just from the sort of power stations, you know, cars, cement manufacture, that sort of stuff. And if we actually look at that, we can see a couple of things. One is that we keep on going up. Last year was actually 0.6% increase, so not quite as strong as 2018. But the really important thing in this graph is the little dip in the middle, which was the global financial crisis. So in that global financial crisis, we reduced carbon dioxide emissions by, you know, basically a gigaton. And so even that, and that sort of shows just how strong and strongly linked carbon dioxide emissions are to our economy. You know, they, even with a big sort of issue like the global financial crisis, there was virtually no impact. If we actually fast forward it to what's likely to happen this year because of coronavirus. So again, even though you know, countries all over the world are in lockdown, etc., is that it's going to have the barest impact on carbon dioxide emissions. So my best estimate is around about 7% reduction in emissions, and that's that little dashed line you can see on this graph. I don't know where we're going to go after COVID-19. We may snap back, sort of thing, to which might be the sort of red dotted line or dashed line, or we may continue to go down. We may see, okay, there are significant possibilities for doing things differently. And the choice between the red dashed line and the blue dashed line is ours. It's up to us as to how we move forwards. We've just heard from Rob about how people can reconstruct after disruption. You can fragment and you can go backwards, or you can actually collectively move forwards, and you can strengthen the bonds between people and how people operate. So these are really fundamental choices ahead of us. And to put this in perspective in relation to climate change, this 7% reduction that we're likely to experience this year, if we're to meet the Paris Agreement goals of keeping temperature down to 1.5 degrees above pre-industrial levels, we have to do that year on year. So this year, 7%, next year, another 7%, next year, another 7%. And if we do it the way we're doing it now in coronavirus, that will be disastrous. So the message here is not that we should do it how we're doing now. We should do something very different from what we're doing under the current circumstances with coronavirus. We need to have smart policies that are sustainable, but they're sustainable environmentally, but they're sustainable in a profitability sense as well. We have to think about how to do things different. We have to think about how we can rebuild stronger. So the focus of this meeting is particularly on drought and climate change and responses to that. So when we actually look globally at drought, big slabs of the earth over the last several decades have had increasing drought influences. So it's not just Southeast Australia. You can see the little square on that map where Australia is. We're in the red, but we're not the only place that's in the red. So big slabs of Africa, parts of South America, parts of East Asia, parts of Saudi Arabia and the Middle East. So we're not alone, but those influences that drive us are subtly different from those that are driving drought in similar places. If we had to look at the place which is most similar to us, there's a combination. One is over in Chile in South America, and the other is over in the Mediterranean in Europe. And both of those are suffering really significant drought that are causing structural change within their agriculture and within their societies. So there is significant impacts already of drought trends which are related to climate change. So drought is particularly driven by a combination of high temperatures and low rainfall. And when we decompose that into the different components, what we see in Australia is, like everywhere else in the world, our temperatures are going up. So last year was by far the hottest on record. It was over 1.5 degrees. The average temperature is over 1.5 degrees above the 1960 to 1990 baseline. So that's a recent baseline that the Bureau of Meteorology does. If you want to compare it with that pre-industrial level, you've got to add another 0.4 degrees. So compare with pre-industrial, we're probably about 1.9 degrees above that level, which of course exceeds the Paris Agreement goal of 1.5. So here in Australia, we're already warming up faster than the global average, and we just keep on going up faster and faster. So you can see that black line in the middle, that gives you a feel for the average change. And you can see it's not just going up in a straight line, it's actually ticking up faster over time. So it's got a curve in it. And so in fact, warming is accelerating in Australia as it is around the globe. So if we just look at last year as an example, last year was the hottest summer on record. We had heat waves over several months, not just in summer. We had the hottest day on record averaged across Australia, and it was beaten on 2 successive days. So firstly to 40.9 degrees and then 41.9 degrees. And so these are, really big breaks in terms of past climate, but the trend is very clear, and the cause of that trend is very clear. It's human greenhouse gas emissions. We've known that for well over 100 years, that if we produce greenhouse gas emissions, we'll warm the earth. And it has resulted in a fundamental change in what we seem to expect, or what we need to expect in terms of our extreme events. So this is a graph straight from the Bureau of Meteorology this morning, which just shows the area, in this case of the Murray-Darling Basin, which has experienced in each year, so each column is 1 year, and it's the area of the percentage of the Murray-Darling Basin that is experiencing what we used to think of as an extremely hot year, an extreme year. And we can see that over recent years, effectively 100% of the MDB is experiencing what would have used to have been an extreme event. So what used to be extremes are now the norm, and they're happening everywhere. If we look at our maximum temperatures, that's the daytime temperatures, which are particularly linked to drought. They're both a cause of drought and they're also a response of drought. This is the map from Australia, again from the Bureau of Meteorology for last year. And our daytime temperatures, our maximum temperatures, on average across Australia were over 2 degrees above the Bureau's baseline. And you can see that sort of orangey, burnt orange colour expands pretty much right across the continent. The only places where you actually get some of the lower temperature sort of colours are where we had a couple of really big cyclones. So in the northeast, we had Cyclone Trevor. In the northwest, we had Tropical Cyclone Veronica. And you can see sort of around the Pilbara, we had a bit of, a little bit of that yellowy colour. But the really big one was Trevor. And if you remember, Trevor came in, dumped huge amounts of rain immediately after a drought. There was no feed around, the animals starved, the animals died of cold exposure. So this happened in the tropics, in the warm months of the year, and it was happening because of climate and climate extremes. Now, if you keep that little picture in mind and then compare that with what actually happened in terms of rainfall, and you can see that there's a really strong link, as I was just pointing out, between high rainfall and low temperatures. So where we didn't have high rainfall, all the red areas, there were really high temperatures. Those places where we had significant rainfall from this map were the slightly lower temperatures. So without those couple of tropical cyclones, essentially all of Australia would have been red, both in terms of temperature and also in terms of rainfall last year. And if we look at rainfall last year, just as a continuation of that trend, we had the driest year on record by far. This was in particular driven by a very strongly positive Indian Ocean dipole. So that's one of the key drivers of variability in Australia. And that drove the worst drought on record over big parts of Australia. And even though it seems a long time ago now, towns were running short of water or sometimes ran out of water. Our rivers were running dry. We had those massive fish kills just over a year ago in the Darling River. But as I pointed out, we also had record rains and record floods, such as that from Tropical Cyclone Trevor. So that land of droughts and flooding rain is just becoming more droughted and more flooded, even in the same year. So those extremes are becoming more frequent in our region as well as other parts of Australia. And part of the story is in rainfall, it's not just about the amounts of rainfall and the extremes of rainfall, it's also the seasonality of rainfall. So these are graphs that come from Dave Stevens over in West Australia. And what he did was he looked at the sort of rainfall seasonality in the past, which is the top left-hand panel. So that's for 1900 up to the end of last century, 1999. And then there's the years subsequent to year 2000 in the bottom right-hand panel. And essentially the key message here is that the northern summer-dominated rainfall is moving south and the dry centre is moving towards the coast. So you're getting that sort of expansion southwards and you're getting the dry centre pushing out towards the wet areas on the coast. And so as a consequence, you can see sort of the logic there is it's not only becoming drier significantly in various parts of southern Australia, but also in a sense a bit more tropical. And so on a cold, frosty morning in Canberra or Wagga, a bit more of the tropics mightn't seem such a bad idea. But the problem with more tropical and more summer-dominated rainfall is it's more variable and less efficient than that rain that falls in the winter months. So this is essentially a recipe for more variability and less crop per drop because of that seasonality change in rainfall. Now, just to sort of give you a bit of a picture of what that means in terms of your operating environment, what I've graphed up here is a really simple graph, which just shows on the bottom rainfall and on the side temperature. And each of those little dots is 1 year of record for southern Australia, so the southern half of Australia. So what this shows is the years pre-1950. And you can see, just like I sort of showed you with those temperature and rainfall graphs, when we have cold and wet conditions, or cold conditions, we also have wet conditions. Or the flip side is when we have really wet conditions because of high rainfall, we also get cold conditions. And the other part of that is when we have dry conditions, we also get very hot conditions. So that water, which would have evaporated from the soil or from the leaves of our plants, actually cools our landscapes. It cools the atmosphere. And when we don't have that water, when it's really dry, we get really hot as a consequence. And you can see I've just drawn a simple line between those, which actually shows that relationship between hotter and drier and colder and wetter. And I've drawn a sort of a little ellipse, a little oval around that sort of combination of years. So you can see that's the sort of operating environment that someone would have been operating in pre-1950. Now, if we actually then look at two other periods, the period from 1951 to year 2000 and the years after year 2000, we can see that that fundamental relationship between hot and dry to cold and wet is very consistent across those different periods. The slope of the line is almost exactly the same across those periods. But what you can see when we combine them and put them one on top of the other, you can see what's happened in that time frame. That now, if we're looking at post-2000, there's almost no overlap in terms of our operating conditions compared with someone who was operating a farm in Wagga or anywhere in Southern Australia in the pre-1950 period. Those little ellipses almost do not overlap. And within a year or two, there will be no overlap. We will be in uncharted territory. And the reason I say that, if you look at the top left of the red ellipse, you can see I've got bolded 2019. That's our future, unfortunately. Not every year is going to be like that, but we're going to be pushing these ellipses up and towards the left. And you can see 2019 was such a massive outlier compared with everything else that had happened before. So one of the messages, yes, there's a warning sign, but one of the other messages is if you could manage 2019, you're going to be able to manage a lot of the conditions that are coming down the track towards us. But it's not all about higher temperatures. It's also about increasing frost risk. So some parts of Australia have reducing frost risk, particularly up in the north. Some parts of Australia have increasing frost risk, particularly the southeast. So this is a simple graph which tries to paint out the sort of frost risk on a decade by decade basis to show how this is changing. So this is work from Steve Crimp, and this is actually a graph for Wagga. So what this shows is on the bottom, it shows temperature. So that's your nighttime temperatures going from 2 degrees, which is a light frost, down to -2, which is a heavier frost. And on the vertical axis, it's day of the last frost, the 10th percentile of the last frost. So most of the frosts will happen before this day. So 180 days is halfway through the year. Day 300 is like the end of October. And so this little triangle here essentially tries to paint out that picture of the frost risk. So you're getting more heavy frosts in the middle of year than you do in the late year. So you get lighter frosts as you travel through the year. So this is the picture of frost risk in the 1950s, 1960s, 1970s, 1980s, 1990s, and year 2000s. And you can see from that simple graph just how significantly frost risk has changed in your part of the world. And the reason this is changing is linked to climate change. So even though on average, the temperature has increased, so Wagga's gone up in terms of temperature, so on average it's warmer, but what's happening is climate change is pushing our big high pressure systems further south than they used to be, and they're picking up super cold air from around Macquarie Island type latitudes, south of New Zealand sort of latitudes, and they're bringing that up over the southeast of Australia when those high pressures track across and the big winds come in from the southerly ocean, and they're super cooling the land. And that's why we're actually getting these frosts. And so there's a real problem here because the frosts are getting later, but the plants are budding and getting to fruiting earlier and pollination in the case of crops. And so that's a double whammy where you're actually increasing the risk significantly, both as a result of the climatology, later frosts, and also the biology, earlier plant responses. So you're getting an increased overlap of that window of biological risk and climatological risk. And all of this is already impacting on productivity and profitability in Australia. So this is a study which came out from ABARES just a few months ago. In this case, it was one on profitability. I had a previous study 2 years ago which looked at productivity using the same technique. And essentially what this did, it was it tried to take out the management and technology signal, which is pushing our yields up and our productivity up in our broadacre cropping zones, against the climate changes which are dragging us down and backwards in terms of productivity and profitability. And unfortunately, this part of the world is actually one of the hotspots in Australia for reductions in productivity. And this is happening already. This is not looking out into the future. This is looking in the rearview mirror and seeing what's already happening as a function of climate change. Those changes in temperature and changes in rainfall, rainfall extremes and frost, etc., that are happening already. And particularly down in Victoria, more than a third is the estimate of reductions in profitability as a function of climate change. And looking at fires, so our fires last year is just a continuation of a long-term trend here in Southeast Australia. So they made global news last year. They were, huge news globally. We had an earlier start to fire season, which is just continuing that trend. We had new records set in terms of our fire danger index, breaking the previous sort of ideas of what the bounds of fire danger index were radically. So if we actually look back at the history of the fire danger index, when it was formed, it went from 0 to 100. 100 being the worst conceivable circumstances. That was how it was scaled. The fires in Canberra in 2003, they were 118 on that scale. The Black Saturday fires in Victoria were 180 on that scale. And we've seen events which are 215 on that scale. And that's already happening. So we're seeing this massive change in our fire risk already as a function of climate change. And we know that fire danger is a function of largely 4 things. It's a function of drought, which dries out the fuel and causes leaf drop in our southern forests. It's a function of high temperatures, especially daytime temperatures. It's a function of strong winds, which particularly in front of frontal systems, which get squeezed between the front and the high pressure systems. And it's a function of dry air. And all of these things are changing because of climate change. Our droughts are getting worse. That was the first graph that I showed you. Our higher temperatures are getting worse. That was one of the other graphs. Our strong winds associated with those frontal systems are getting worse and are projected to quadruple the number of events that are like that over the next several decades. And our air is getting drier, unfortunately. That's what we call the vapor pressure deficit. And when we look, this is very recent work, when we look across the globe, the air is getting drier. The vapor pressure deficit is increasing and it's projected to increase further. So if we look at this graph, which goes up to 2100, that's the increase that is projected across the globe. Now, vapor pressure deficit is really important. It's like the inverse of humidity. So high vapor pressure deficit means really low moisture in your atmosphere. The amount of moisture that the atmosphere holds is much, much smaller than what it could hold at that temperature. And unfortunately, high vapor pressure deficit not only encourages fires, that dryness of the air, which allows fires to spread much quickly, it also reduces the effectiveness of our plants. It reduces the water use efficiency of our crops and our pastures. It increases the evaporation from our dams. And this is one of the other trends which is not frequently talked about, but which should be talked about. So, and lastly, these things add up, amongst other things, not only to profitability, but also to changes in the water available for things like irrigation. So this is a map which came out from the IPCC, which shows the runoff change in percentage per degree warming. Remembering we're already at about 1 degrees across the globe, 1.1 degrees compared with pre-industrial. And if we go, say, to 2 degrees, we multiply these numbers by 2. So 2 degree scenario means we've got 20% less runoff in the Murray. If we go to 3 degrees, it's 30%. And unfortunately, this is what we call a median estimate. And unfortunately, at the moment, we're tracking on the worst case estimate. And we saw in the Kilty report just a week or so ago, the impact already of climate change on water availability in the MDB. And so this is, again, one of these things that's accumulation of multiple changes, changes in rainfall, changes in temperature, changes in vapor pressure deficit, which are all linked to human activity. So unfortunately, what I've said is not great news. I mean, there's not a huge amount of positivity in there. And so when, you know, and I'm really sensitive to this because, as Rob was talking about, in times like we're experiencing with COVID-19, it can be already stressful and additional information can increase that stress. But the point that I'd make in the first instance is that if you actually look at Australia, there's people who farm quite successfully in places which are like the future that Wagga is heading towards. The places that are warmer and drier than have more summer-dominated rainfall. And people can make a buck and they can have sustainable farming in those places. So it's not hopeless, it's just different from what you've done before. So this slide and the last slide, which is a summary, Peter, is just a little bit about looking forward in terms of what we can do. And there's lots and lots of things we can do in terms of our farming systems, in terms of our food value chains, in terms of our catchment management to manage climate change. And I haven't got time to go into them at the moment. But the point I'm just making is it's really important to think about this, not only in a tactical sense, you know, what am I going to do next week, but in a strategic sense, what am I going to do next decade? And so for me, it's important to talk about strategy. So for me, a strategy is simply, to put a very, very simple sort of description on it, it's the game you want to play, and sometimes it's the game you don't want to play, and how you think you can win. You know, why are you playing this game of our existing farming systems? And why do you think that's the best thing you can do? And if you're thinking about that, how are you going to organize yourself in terms of climate risk management? Are you going to look backwards in the rearview mirror to the old climate? Or actually, are you going to look forwards out the windscreen to the new climate? Are you going to turn your headlights off? Or are you going to turn your headlights on and perhaps put a few big beamer flood lamps on there as well? How are you going to value your assets, not just your land, but also your knowledge, and also those social connections that Rob was talking about? And if you value them, how are you going to look after them in a changing climate? What sort of farming are you thinking of doing? Is it the farming for commodities that you're already doing? Or is it niche crops, niche opportunities? Is it farming for energy, like wind farming or solar farming, solar PV? And there's people from Farmers for Climate Action who are doing this with wind turbines on their farm, earning a good income stream, as well as having their traditional grazing systems. Is it farming for carbon and buying into the carbon markets? They're not really well developed here in Australia yet, but I predict they will be. Is it farming for biodiversity? We've got a biodiversity crisis globally and in Australia. We're the capital of extinctions for mammalian species here in Australia. So there's alternative options, and these are not either ors, they can be ands. So you can have many strings to your bow, and that's the thinking about strategy that needs to happen in a changing climate. What are the strings that you're going to attach to your bow, and what type of bow have you got? So a real quick summary of what I've talked about. The climate is changing, and to a huge degree of certainty, it is changing due to human activities. And because we continue to produce lots and lots of greenhouse gases, and our trajectory is not towards decrease of those, a lot more change in our climate is likely. In our region, overall, it's likely to become warmer and drier. There's going to be likely less rain in autumn and winter when that rainfall is really effective, effective in terms of our crops, effective in terms of our rivers, and maybe a bit more in spring and summer. So it might become a little bit more tropical, but also more variable, more influences of things like the Indian Ocean dipole and El Nino on our climate variability. Frost in spite of the warming that we're experiencing, is likely to continue to be a problem and possibly expand as a problem over the next 2 or so decades. And then it may get overtaken by that warming trend. Our extremes of all types are likely to be increasing, both in terms of the magnitude and the frequency in which we experience it. So whether that's droughts, floods, heat waves, or fires, we need to be ready for more of that sort of bad news. So unfortunately, there is not much good news in what I've said, but that just means it's more important than ever to be prepared tactically to respond to the short term, and to be prepared strategically to respond to the long term, and to wrap that climate response and climate strategy into your broader business strategies and into things like succession planning. And just lastly, to emphasize, there are opportunities here. There's opportunities to learn from each other. There's opportunities to learn from other places. There's opportunities to learn from other industries as we rebuild and go ahead stronger than ever. Thank you.
Thank you, Mark.